Guys, we're back. How's lunch? Was it good? We caffeinated again. These seats, they're nice, but I feel like some caffeine is mandatory. Yes, no? Well, we've got an afternoon full of talks for you guys. One of them might be featuring in the comedy show later today. See if you can work out who that is, based on how... I feel like now I'm setting them up for failure by like hinting that their like talk is going to be funny. Probably won't be, because that's not the purpose. But yeah, we've got some awesome talks for you guys in a bit. We also have a machine here that seems to be making some noise based on some works that might be happening outside. So in case, I'm like foreshadowing in case something like explodes or some weird noise coming from here, that is why, in case any of the speakers like Dave, what's that ringing sound? It might be from down here. But it seems to have stopped just now, which is very, very exciting. So can I get you guys to give a very warm welcome to Sima Mousavi, who is AuScope's National Outreach Manager.
Hello, everyone. Before I start, whose sunglasses are these? Please come to me later. Okay. It feels weird. Okay. Before I start, hopefully you're not feeling sleepy, because I am, and wish me luck in this universal nap time. So, I'm talking on behalf of the AuSIS team and our mascot, who insisted to come along today. So, the AuSIS team, over the time, the AuSIS team has changed faces, logos, and computers from Windows 7 to Windows 11. But what has stayed constant, aside from Malcolm's photogenic smile, is our mission to bring seismology into classrooms across Australia. We are a small but mighty team of scientists working with school teachers to make sure the next generation doesn't think a fault is just something you apologize for. So, Chapter 1, AuSIS, a permanent seismic network. Before I talk about outreach, it's important to remember AuSIS is part of Australia's seismic monitoring system. Here is AuSIS network. So far, we have installed 50 seismometers at schools across Australia. 50 research-grade seismometers. Maybe I should keep it here. Each capital city received one, and the rest were deployed in rural and regional areas. Each of these triangles shows a school site that sends us data in near real time. Data goes to AuSpace and also to AuScope, formerly known as IRIS. AuSIS is Australia's second permanent seismic network, after Australian National Seismograph Network operated by Geoscience Australia. Our school stations fill in the gaps within the national network, improve Australia's seismic coverage, and provide high-resolution data for researchers. Now we are taking this idea even further through AuScope with Seismology on Country project. Through AuScope's Opportunity Fund, we are establishing 5 new sites and upgrading 3 existing sites of AuSIS. These sites stretch from Torres Strait Islands in the north down to Yalata Aboriginal community in the south. These sites strengthen the national network, but more importantly, they build partnership with Aboriginal and Torres Islander communities. As always, students will be the custodians of their own seismometers, caring for them, learning from them, and connecting science with culture and country. This is a beautiful alignment of science that listens to the earth on country where people have always listened and care for it. Now it's time to talk about outreach. So AuSIS is a program for translation where we turn science or seismology into outreach, education, and engagement. Every year we have a solid plan to visit our schools, and of course, visiting our rural and regional community is a priority. One of the most special trips that I had was a visit to Ernabella School in APY lands. So I had the privilege of living in the country for 3 days and working with the students. Students learned about earthquakes, seismology, seismic waves, geological timescales, and a lot more. One of the interesting things was that many of the elders remembered magnitude 6 Petermann Ranges earthquake that occurred in 2016. That linked their experience. That linked my science with their lived experience, and the science communication went well and very engaging. Here, I want to give a special shout out to Grace, who joined me in this trip. A unique experience that remained with both of us, showed how meaningful these connections can be. Oh. Now, moving to west, to WA, Kulin District High School. So this photo shows when the students are doing foodquake. Every outreach session ends with foodquake. It's the time that the students love it, and it's the time that students get very excited because it is the only time that they are officially allowed to go nuts without getting into trouble. So, to be honest, I'm the person who gets more excited than students. So, it's not all about schools, we also engage with public. At a Radars game at GIO Stadium, against someone who really doesn't matter, we recorded people's Viking clap.
We want you to make the biggest recorded footy quake in the world.
Okay, it is over to you now to bring out our team!
National Science Week. National Science Week is the loudest, busiest, and most joyful time of the year for us. It's the time that we run our Food Quake of the Year competition. We ask the students to be creative in making seismic waves. Biwa State High School in Queensland took the competition to a new level. They spelled out their school name in Morse code using seismic wave. And here are the faces of the happy winners. They got the trophy for a year. This year, we tried something new. We had AuSIS's short film festival called EarthFest, My School, My Seismometer. We invited all the students to tell us their seismology stories. And it turned out to be even more fun than the foodquake, at least a lot easier on students' feet and knees. Here are the schools that participated in the competition. Each of the films showed incredible creativity. I invite all of you to watch the films. And the films are playing in the foyer, where you eat your food there. And Georgiana Molloy in Busselton made it to 7 News in WA. So their film is called Agent Tremor. Let's watch it.
Agent Tremor, we have a situation. Mysterious tremors have been detected right beneath your school. Your mission, find the source. Learn what's causing the shakes. Report back to me in 3 minutes, if you're still standing.
The epicenter. Could it be playground quakes or library landslides? These aren't random. I need backup. Time to call the science experts.
Seismology is the study of earthquakes. Earth's plates move, which create waves.
And we can track these waves with a seismometer, like this.
This records seismic waves. It even picks up distant earthquakes.
Our school is part of a national network. Real science, real time.
Wow, I never knew we were a part of something this big. I found the culprits, earthquake drills, playground practice, all logged by the seismometer. Mission complete. No tectonic doom. Just curious students and cutting-edge science. Seismology helps us understand our world one shake at a time.
Well done, Agent. You've earned your certificate and some serious seismo swag.
Well,
Georgiana Malloy, a proud participant.
I'm sure Rebecca, the teacher from Georgiana Malloy in Basildon, will watch this. So big shout out to Rebecca. Now, the students have done their hard work. It's your time to vote. You have 24 hours, which is more than enough time, to binge watch all the films in 10 minutes and form some strong opinions. So please scan this QR code to watch the films and cast your votes. Thank you so much.
How good. Well, without further ado, let's introduce Bryant Ware, our next speaker. Thank you so much. We got a cry for a question. Oh, my bad. Do we have any questions for Sima? Any questions? Yes, over here. There we go. Great. Thank you. The question was, are there any plans to scale up the program?
To scale up the National Science Week competition or AuSIS? Traditionally, we do Science Quake of the Year. This time, Malcolm came up with this idea to hold a short film festival. Maybe next year, we do something else with a larger scale.
Yeah, I think that would be a great initiative to engage kids with earth sciences, and also that will help to address the problems that we were discussing before.
Exactly, yes.
How do we teach kids about earth sciences?
Like all the things that we have in our power to visit the schools, talk about earthquakes, seismology, and tell them earth sciences can be a career path. And I was talking to Brent, and I said, this is not just one person or two people's job, it requires an army. So our arms is open for all people from AuScope or Earth Sciences to join us in our outreach programs and help us to do it in a wider attempt. Yeah.
Love it. Thank you so much, Sima. Thank you. Let's get Bryant up. Bryant is the coordinator of the AuScope Geochemistry Network. And I'll just get your slides up. Here we go. Maybe? Is that yours? Here we go. Take it away, Bryant.
All right. Great. Thanks, everyone. We'll stick with some education and outreach. So I'll present on a project that we're just getting started. So some of the stuff I'll show we've worked on a bit, and some of it is, let's say, some aspirational ideas that hopefully sound pretty great. Looking for feedback on how people think it could go, maybe with experience in education in the audience. And hopefully we'll be rolling some of it out early next year. So I had a great, so I'll skip over this because we've done a little bit of it, but I'm in Perth, based in Perth. So just acknowledge the Whadjuk people, the Noongar Nation, and Burlu. But so led in pretty nice this morning with this, that in the panel discussion, I think we touched on a lot of these, so I can get to a few more pictures. I'll kind of burn through a bit of this. But as we discussed a bit this morning, we see a decline in geoscience enrollments. So this is a report from the Academy of Sciences, so it's pretty nice that we're in this very cool dome. And I liked this one from another report that showed some of the preconceptions for geoscience when students are thinking about career paths. And ones that really stood out to me were just sort of boring content. I liked this one, not future focused. We think about the past. And certainly I think we all know that, you know, maybe a negative stigma in mining and such. So there's also, and this was directly brought up, lack of geoscience in senior high school curricula. And that's also been found to kind of be the sweet spot that we're really missing out when people are thinking about their careers. So we got to thinking with all of this, well, it would be great to look at some education and outreach ideas with some of the work we've been doing in our project. So I'm part of the EarthBank project. Brent presented on it this morning, so I'll skip over a little bit of going in the background of that in the platform. So hopefully everybody was here for that, or at least enjoy and catch up on some of the cool pictures. But of course, despite this decline in students, we know that geoscience, and for myself, geochemistry, what I think about most, will be very important moving forward for, as this great picture shows, geoscience for the future. So I thought it was really great hearing some of the discussion. I was even just thinking back that I did my undergrad, actually, I think now 15 years ago, which is pretty wild to think about. But I'm not quite sure much has changed since then in the way geochemistry, at least, has been taught. So what we're looking at in our project is some of these future directions. So how can we modernize geoscience education? And a lot of the talks this morning, in addition to the panel discussion, of course, talked about the amount of data that we have, that we've generated, of how useful the data we've already generated for, and of course, that we'll be producing a huge amount more data in the coming years. And really, modern curricula, or curricula as it stands, doesn't really prepare students, which was mentioned directly in the panel discussion, which was great. So what I'll look at is two kind of aspects we're working on in the EarthBank project. One is called this Inspire STEM Education, specifically look at ours that we've got up and going in Western Australia, and then an opportunity fund that we are just getting started on called EarthBank in the Classroom, maybe changing to EarthBank in Schools. So we match all the others. So the Inspire program, it's a national program, but through AuScope and the EarthBank project, we've supported bringing it to Western Australia. We're actually, I would say, just about almost exactly a year into when we first launched. So what this program is it takes a desktop SEM, loads it into a car, takes it out to a school, leaves it there for a week or 2 weeks, however long they can do it. And the teachers can then drive what they use it for with education. So we start out by getting together with the teachers and teaching them how to use the desktop SEM, and then they can work on how it fits best within what they're teaching. And of course, it can touch a wide range of subjects, not just geoscience. Of course, everybody loves looking at insects. They're extremely cool under these. But what's so great about it is it's extremely easy to use. So the students can really get on, and they can be the one driving it. It doesn't have to be something that they just watch happen. So they can prepare the mounts, they can load the mounts into the instrument, and then they can pilot the instrument, basically. And here's just some feedback we have, I think in the last year. Maybe these aren't quite up to date, but we've done about 17 schools, which means about 2,000 plus students engaged. So I introduced that one first because one part of our EarthBank in the classroom is to utilize this program, seismometers in the school. So I'll spend most of the rest of my time looking at an outreach one that utilizes this SEM. If we have some time at the end, I'll go into a little bit of our plans for tertiary. But our EarthBank in the classroom project is to help modernize STEM teaching of earth and environmental sciences at all levels, so from outreach to tertiary. And our aims are to develop, hopefully, training modules or education modules that can be, that basically aren't built for the way the curricula is for myself at Curtin or in Melbourne, but they can be rolled out to a number of different schools, another number of different, it could be industry, whatever. So as I've just gone through, we have kind of 3 targets we're looking at. So an outreach and then 2 university level ones, one within the classroom and then one kind of incorporating some field. So we've gone farthest, I guess, on outreach. So I'll focus on that and then touch on university within the class on kind of the ideas we have as we just kick off, and then just mention the field ideas at the end. Okay, so to the outreach side. What we have is a Cluedo-style geoforensics, or Clue, if you're like myself from the States. So disaster is in the school science lab. The class wombat has been stolen. Sand found at the scene holds vital clues, and 6 suspects are on the list, each with access to the classroom. Their boots have been collected, and now it's up to you. Examine the evidence, analyze the grains, and uncover the truth using cutting-edge scientific tools. Can you crack the case? So, to win, you must utilize several forensic science tools to determine the answers to these questions. Where is the class wombat, and who did it? I mean, how cute the wombat is. So, what we lined up, I'll kind of go through. Our ideas is there'll be kind of 3 stations. Those students will start with macro observations. We'll have the sand, again, that was collected at the scene and from each suspect. So they will use their naked eye, they'll use hand lenses, a lot of macro types of observations after splitting into teams, and be able to start eliminating some of the suspects. And then they'll be able to take their 4 that they have and take it to use some of the high-tech scientific equipment. A little wrinkle that we'll give them is that they don't have enough money to pay for all 4, so they have to choose 3. We've got to add a little bit of realism and also chance. So they'll take these in, they'll image them, they'll look at them, compare it with the suspect one, come up with a who did it. So we accuse Professor Pumice, but we need to know where the class wombat is held. We know maybe who did it, but not where it is. So this is where the EarthBank platform comes in, where they will then take what they've observed in the SEM and look at these various pie charts. And the way the idea of the way of arranging it is that it can be done by color and size and shape, so it can be quite scalable. So they could see which one matches what they observed. So I saw one with with some nice shaped crystals and some shells. And then, of course, each team can make their full case and come up with who did it and where. And then the last part of our group activity is for everybody to kind of come into a court of law and present their case. So Professor Pumice stole the wombat, and she's in Sydney. Or it was Colonel Meteorite, and the wombat's in Brisbane. Or Miss Opal hid in Hobart. And then, of course, we'll have a winner of where they were, and hopefully a fun time is had. So touching on with some of the chants and the ways to scale it up. So of course, with the EarthBank platform, we can host geochemistry data. So there can be ways to introduce some actual data into this game. I have the pie graphs up there because they're designed in a way where you can just look at shapes and colors to determine, but you could also dive in a bit deeper to that. So you can look at actual mineral types. So this sand is made up of feldspar, it's made up of quartz, shells, accessory minerals, and so on. And another key part of it, again, with adding a little bit of chance with how much funding they have, is, of course, they might just focus on the shells and then miss the accessory minerals, for instance. So hopefully it's just hard enough that it's all fun. All right, so in my not much left time, I'll look at a little bit at the tertiary one. So this is sort of our idea. It's to create a semester-long course where students can look at data, so sample metadata, they can look at instrument data, they can play around with it in a more traditional sense, so looking at, in this image, Excel files. But then they can upload the data into our EarthBank platform and start to build over weeks more data and a bigger, wider understanding of the area. They can plot the data that goes in, add some age data, so now they can tell how it was formed, when it came, and then as Brent showed, with the G-plates tool that we have, they can take it back in time. So through the course of a semester, they can really build an understanding of a complete area and learn handling multiple types of data. And to finish off, I'll just throw our last kind of idea that we haven't started really developing in any way, but is to explore how we can get this into the field a bit. So how can we relate the field observations and the field work that students do in their field trips during class and relate it into the platform and the geochemistry data. So we could have, this is an example from Broken Hill, where students went out to kind of trial a little bit, where they went out, did their field work, but then also could come back to the platform and interrogate the data. So, thank you.
Good. We've got time for just one question. Do we have one question? Is anybody interested? A question? Question going once. Question down here.
How good is that? That's awesome. The competition where, well, the forensic competition, have you got an element there where, because you say you get them to budget, have you thought about an element where you might get the groups to learn how to collaborate between each other? So if they can't each afford, then they could share data or something.
Yeah, that's a great idea. We kind of thought of just pitting them all kind of, not necessarily against each other, but to sort of stay pretty isolated. But that's a great idea to kind of get them to work on collaborating between groups and sharing knowledge in some way. Yeah, I like that.
Thank you so much, Bryant. How good. Now we have Blake Allen, and Blake is the program leader of the Coast RI at Deakin University. Blake, I'll just get your slides up.
Here we go.
Hey, that's working better. All right. Thank you for the introduction. Today I'm going to be talking about the National Coastal Drone Program. Great news, it has drone in the name, so maybe we don't have quite the problem of being perceived as stuck in the past compared to some of the other groups that have said that that might be a problem. Drones usually do grab attention, at least with the youths and things like that. They're still seen as pretty fun. My talk today is going to kind of give you a bit of context of where this program fits within Australia and funding. Then we're very new, so I'm going to talk about what we're trying to achieve and then a bit of how we're going to achieve it. So we're part of CoastRI, which is the Coastal Research Infrastructure. It's got 11 different groups providing funding into it, and it's got a vision of creating research infrastructure and connecting land and sea within Australia in lots and lots of different ways. The objective is to gather comprehensive and integrated scientific data from diverse sources, enabling better understanding to predict and address the opportunities, because coastline monitoring is needed to answer critical questions about the future of Australia's coast. So within that is our team. We're part of the National Coastal Observation Facility, and it's got two components. It's got my component, which is the National Coastal Drone Program being run at Deakin University, and we're focused on low-cost drones, and I'll be talking more about those. We also have a component of fixed cameras, which is being run by the University of New South Wales, and we tie in closely with the AuScope Long-Range Coastal Drone Program, which Steve will probably talk about its capabilities directly after my presentation. So I work on drones. I have to show cool drone footage. It's just part of it. But the main thing here is that we are establishing a framework that will coordinate regional drone programs. So trying to coordinate workflows, develop standards, and the delivery of that data. Also helping with the procurement of equipment to do this work. And we also want to have a high presence in regional stakeholder engagement when we come to site planning, to working with citizen scientists and traditional owner engagement within this space. We want to develop decision-ready data, and I'll again explain that more soon. And we want to capture and report on the impacts of our facility over time. So we have only really gotten going a few months ago, so we're fairly new, but we have started consultation with the various states and territories. So we're kind of kicking off the program by trying to collate historical mapping. And by doing this, we're identifying, first of all, why has data been collected to date? And so in the low-cost drone space, it's mainly for coastline monitoring, so beach erosion and cliff collapse. Also focusing somewhat on habitat condition and biodiversity, but in the low-cost drone space, there are limitations to this. We think, based on early assessments, that there is at least 1,800 to 2,000 historical data sets in this low-cost drone space that we're going to try to pull together from the various states and territories. What we've discovered very, very quickly is that there is a lot of data sitting on hard drives somewhere within each group. So what we really want to do is try to pull this together, get the metadata right, get all of the file conventions and folder conventions there so that this data doesn't get lost. Because the worst thing that could happen is this data that has been collected and has been funded disappears when a hard drive breaks down or someone leaves an institution, and we all know that happens. So we want to do that, and we've also built up what we believe a representative mapping site looks like. This is a bit pushed by Victoria because I come from the Victorian Coastal Monitoring Program, and we make up about 1,200 of the 2,000 mapping data sets that exist. But in general, we are talking about RGB, or your standard visual photogrammetry mapping, to support management decisions. It tends to be of about 3 to 5 kilometres of coastline. Mapping tends to occur about 8 times a year at each site. So somewhere between 4 and I think about 12 is the most that we've seen. That's not true. New South Wales went really hard, and they've got 20 or 30 for some of their locations in 1 year. So there's this time series that's being built up. And then all of the data has RTK photogrammetry correction or ground control points built into it. to achieve accuracy, and there is QA/QC done. So in terms of data collection, so what are we collecting? Well, we're looking at orthomosaics. So orthomosaics being your Google Earth stitched together images and digital surface models. Now with the drone data, these tend to be sub 3 centimetre pixels, and this is the cliffs at Anglesey, for anyone that knows the Anglesey cliff area in Victoria. We tend to achieve a 5 centimetre horizontal accuracy, so plus or minus 2 to 3 centimetres, and a 10 centimetre vertical accuracy in our data, so plus or minus about 5 centimetres. We're then collecting point clouds, so anywhere that we have cliffs and things, we also do oblique imagery so that we get a good picture of what that cliff face looks like, and this is then a point cloud of that same area. We build triangular meshes. Some softwares, some analyses prefer a singular mesh model instead of lots of points, so we develop those as well. Some locations have multispectral data. Multispectral data is sometimes calibrated, sometimes not, depending on who's collected it. And it does have some relevance for habitat and biodiversity mapping, and we are hoping to support this within the program. And then we have this idea of decision-ready data, which I mentioned before, and I wanted to define it at this point, which is data products which can be directly used by land managers and researchers without further processing or analysis. So the data that comes out of the softwares that we use often needs some sort of cleaning or management, and that is done by our team, it is done by them. So the data that comes directly out of the processing we call analysis-ready data, because some people want to use it at that level. But what we've discovered in our program, working for years with local councils and governments in Victoria, is that they don't know how to do that next step. So we've put a lot into having the data ready to make decisions, doing the cleaning, doing the QA/QC, and all those sorts of analyses so that the data should be ready to go. And we want to take it one step further with our decision-ready data so that it's not just the data sets, but it is a level of analytics that is done on the data. So I'm going to present what we developed what DECA has developed in Victoria. It's not me anymore and hasn't been for about 3 months, so I'll stop saying we for that one. But they have the thing called the Victorian Coastal Monitoring Program, and they developed something called VCMP sites, which is 6 measurements that come from the drone, the satellite, and the aerial imagery. And it looks at shoreline position. So we take shoreline position as 1 metre AHD in the open coast or 0.5 in Port Phillip Bay. We look at transects, so 30 metre transects, so transect spaced 30 metres apart along the entire Victorian coastline. Looks at shoreline trends, so the trend of what's happening along that transect on the shoreline. We then developed shoreline time series so that you can see how that shoreline is changing. Cross-section profiles for each transect, and the morphology and substrate, because that can be important too. We found that this was good, but local councils and governments wanted something a bit quicker and a bit easier to read, so we took it another step, and you can read about this, it's been published by McCarroll et al. We took 6 analyses and made what we call the coastal erosion indicators. And so these are what we're calculating. I won't go through all of them, but we developed coastal erosion warning indicators. So a traffic light system based on these measurements here, and again, it's published so we can link back to it. So the erosion warning indicator gives you a quick reference to, am I seeing problems in my area, yes or no? We then have the hotspot detector, which means, okay, I'll go one step further. Where in my area is seeing problems? And it's a simple color-coded method that suggests that maybe you need to do further analysis because something is happening. Why it's happening, we don't get into, but we have had a look at it for some areas, like this area in Apollo Bay, where there has been renourishment efforts and things like that. And this analysis here by Nicholas Pacino took that one step further and tried to have a look at the differences between what was happening on the coastline based on the management of that coastline. But we don't think we can get to that level for all the sites we're hoping to do. So we have a few support options for our regional people. So if they don't have much coastal drone monitoring going on, we're hoping to establish new sites, setting them up with equipment and training, and helping to develop those decision-ready data products. If they do have existing sites, it's going to be a subset of the above. They may want to expand or co-invest in growing it further, and we should be able to help with that. Project specifics are that we've got about $250,000 to spend in each state and territory that has coastline, sorry, ACT, and we'll be spending that over the 3 years for each location. We're looking for one-to-one co-investment with the groups that we're talking to, but it can be cash, staff time, equipment, what have you, so that, you know, how much we do depends on the skill sets that they have. We have centralized funding for people such as myself to then support them with things like training and getting up and running and questions. We don't have a set model for how we're going to do it because each state and territory will have different requirements and it will cost different amounts of money. In Victoria, our coastline is very accessible. In somewhere like WA, it's going to cost more if they head further north. So we're very much working with our regional partners to work out what can be done with the money that's available. Similarly, we have recommendations of equipment, but if a state or territory is up and running, we're going to work in with what they have. What we're going to focus on is how the data is collected and making sure that the end products meet a certain level of accuracy so that we can move forward with that. And we'll have that centralized support because one of the big sticking points that we have found working with local management and local groups is that putting the drone up in the air can be done. The hard part is getting something useful out the end, and so we can be, as a central group, the group that tackle that for them. They can be the boots on the ground, we can be the people doing the analytics and the processing. We really want to get the local stakeholders involved and the rights holders. We've been doing this in Victoria. It's really good for both creating citizen science awareness of what we do, and we did that in the Victorian Coastal Monitoring Program, but also creating a custodianship and an ownership of that beach and understanding what's going on. It's a real value add that I think is probably one of those ones that's quite intangible and so doesn't really make it into metrics all the time, but that outreach and that work with the community is really important for us. And where possible, we will be doing this as citizen science, following the model that we had in Victoria, where we provide training, equipment, insurance if it needs it, and oversight, but it can be a community group that go out every 6 to 8 weeks and collect the data. These are the proposed or known mapping sites in Victoria for the low-cost drones, which is what we're doing, but we're tying in with the other groups that are doing things within Coast RI, so the long-range coastal drone program, which is still developing some of its sites. We're working in with the Wave Boys and the fixed camera network, and we're trying to create some locations in each state that will be what we call sentinel sites or synergistic sites that will bring together all these technologies to get a better idea of what's going on. So this is the group running the National Coastal Drone Program. Professor Daniel Iridiacono is here too, so feel free to accost him with questions as well. I'm here, and we do have a data scientist starting in January. Here are the references. Sorry, they're going to be quick, but I can always provide them later. And thank you very much.
Cool. Do we have, I think we've got time for just one question. Do we have a question? Going once. Yes. It's okay, I'll come to you.
Are the routines and the workflows that you're using to analyze the drone data going to be available to the community?
So the protocols and things that we come up with, yes. We are trying to make everything available as much as possible. Turn already do make their workflows available, but they are very specific to what they do. What we're going to try to do is develop a workflow that is not specific to a drone. It's more about how you do it and explaining why you do it in the way that you do it. So that hopefully we're not going, you need this drone to do this work. It's the, okay, if you want to get into coastal mapping, here's how we suggest you go about it. Here are some ways to process and QA/QC. And file conventions and folder conventions, we're working with as many groups as possible to try to standardize that across Australia.
Thank you so much, Blake. How good. So we have our next speaker. We've got Stephen Micklethwaite, who is help me. How do you say it? Micklethwaite, who's the director of the Drones Collaborative Research Platform at the University of Queensland. Here we go, and I'll get you set up. Thank you so much, Stephen.
Should we work? Great. Oh, awesome. So I don't think I'm the comedian in this session, although some people say my name and my wardrobe choice are hilarious. And we better crack on. So very quickly, I also wish to acknowledge country, and particularly the Jagera Tuggerl people from Brisbane area, where obviously I'm based. Drones Collaborative Research Platform, that is the name of the UQ node of the AuScope drone infrastructure, which feeds into the CoastRI program you've just been hearing so much about. This very busy slide is just basically to highlight some wins. I can see that copying and pasting across to the AuScope templates left us resulted in a few mistakes, but either way, what you can see here is we've got a fairly well-established organizational structure now. We are servicing the research community, you guys, industry and government, and we have CoastRI and Queensland Investment Co-Investment, which is the RICIF scheme, as big underpinning projects to our infrastructure, and we've been quite successful in a short time in raising some fairly significant underpinning investment. And again, another busy slide. I'm going to get on to the more exciting stuff in a minute, but this is just a snapshot of the kinds of capabilities that we have and are in the process of establishing. So that's remote sensing. It's LiDAR, photogrammetry, multi-spec, hyperspec. It's geophysics, certainly in the magnetic and maybe the EM space. And then it will be also acquiring equipment that can do direct sampling. So water sampling, gas emissions, dust, particulate, things like probes that can measure temperature and so on. And all that sort of equipment allows you to do things like change detection, time series, view the world in extremely high resolution. And because the infrastructure also includes the people, that's a theme that's been mentioned a few times today, we have managed to attract just some of the best pilots and maintenance officers around. And that means that as a research community, you suddenly have access to be able to do flights, complicated flights, with equipment that's very, very expensive that you wouldn't normally be able to afford through a traditional ARC fund, because we've got the compliance sorted and the regulatory side of things sorted, and we can help manage that for you and make it a lot easier for researchers who want to answer very difficult questions from an aviation perspective. This is just a snapshot of some of the equipment that we have and are getting. And the very top left-hand thumbnail is a drone that is carrying a $1 million sensor, a hyperspectral sensor that goes into the shortwave infrared, visible near infrared, co-aligned. That's actually also a success story for this platform. So we've been supporting a Horizon Europe project, and in that Horizon Europe project we've developed technology with European partners which can return hyperspectral information that's calibrated and validated and processed and even to some extent interpreted, so you can get things like mineral maps in real time, so while the drone is flying. And for anyone who does hyperspectral work, you'll realize that that is quite an achievement, because normally it takes weeks to months to do that, make that sort of achievement, get those sorts of results. We have drones as well that can fly for long distances. The drone on the top right-hand corner, the Angel A-Race, can carry LiDAR, really good camera, RGB camera, really good multi-spec, and that can fly for 2 hours solid in one flight. So, you know, you can quickly cover large amounts of ground with this equipment. And we're getting things like bathy LiDAR and geophysical gear as well. But one of the really important areas of development, and Blake just touched on this, and I think one of the questions touched on this as well, is you can have all the equipment and all the sophisticated sensors in the world, but unless you can deal with the data in a sensible way, then you really still have a fairly significant problem. So we're working with partners both in the University of Queensland and hopefully around within the INCRIS infrastructure ecosystem to try and marry all the sensors and the data that we collect with really good data curation, pipelines, and even into the data analytics. Moving on to some of the successes that we've had in this first year. Blake has already mentioned the CoastRI program, and that is big underpinning funding that is coming through AuScope to us. I won't dwell on that, but except to make the point that this is the first time Australia has actually put together federal investment into monitoring its coastal environment. And given that 70 to 80% of our population are in that zone, and that we're an island nation, it's quite astonishing that it hasn't been done earlier. And it's also absolutely, I think it's a real bonus for AuScope and for this community that we're involved in that initiative. So I'm really looking forward to how this project develops in the next few years. And all the long-range equipment that we have is linking in with the programs of work that Blake has just told you about to deliver data that can hopefully have impact both for researchers, but also for local government authorities, for community groups, committees, and so on. So that's, to my end, one of the joys of science, is when you really see your science rolling out and having impact in the community at large. Another success story, Graham, where's he gone? Is Graham Heinsohn still in the room? Hey, Graham, back, thank you. So Graham and I, along with a roboticist at UQ, have worked for the last 2 years and have developed a proof of concept where we can take what's known as a geomagnetic depth sounding instrument, and we can deploy that by drone and then go back and retrieve it. Now, this is a proof of concept, but the idea here is that we could go and we can begin to scale this up. And what GDS does for you is it gives you data that's it's similar to MT. So it's not going to replace MT, but it's very, very complementary. And working with Graham and an early career researcher named Gemma, who's unfortunately now moved back to Europe, we were able to show that the GDS, which is the data on the left, can return MT-like information, which is it's very consistent with the MT on the right-hand 3 panels. So I think that's a really promising technique, and the point there is that with this instrumentation, we have the potential to maybe get out into parts of Australia or elsewhere around the world and deploy hundreds of sensors in the time that you would only be able to do 5 or 6 ground-based sensors. Now, another success story, this last few months, I just got back from Vanuatu. We were approached by the Earth Observation Research group at UQ who won funding. Actually, I was involved in the proposal. We won funding to go and monitor the coral reef environment of the island of Pele in Vanuatu. This was an astonishing project. So the project leader he grew up in Vanuatu, although doesn't have Vanuatu heritage. He grew up in Vanuatu, so he knew the chiefs and the co-chiefs on the ground. And basically, he helped us co-design this project. So we were talking earlier today about science that's hand in hand with the traditional owners. This was the first example I've ever had where that happened. So we have a research project where we're hand in hand co-designing it with the co-chiefs on the island of Pele. They are already very cognizant of climate change and sea level rise because they're seeing their villages washed into the ocean in their own lifetime. They're worried about their food source in the next 30 years because they're seeing their fish stocks dwindle. And they're worried about the next generation because they're seeing these kids growing up with where economy, job prospects are also dwindling. But the coral reef on their doorstep opens up an opportunity for ecotourism and so on. So we've run a project with the Earth Observation Center where we married drone footage, multi-spec, LiDAR, and photogrammetry with scuba transects where they were collecting photos underwater, with satellite data, and then linking all that into hydrological modeling. We also, while we were over there, did schools outreach program, taught the kids about drones, did a paper aeroplane competition, and it was only afterwards did I discover that the school wasn't even able to run exams this year for their kids because they didn't have any paper. So that was a bit of an eye-opener. And then it just so happened that Vanuatu, the local government found out about a project, and they got in touch with us, and they actually asked us to come and use the drones while we were in country to also map and monitor all the damage that they suffered from the earthquake back in December, which was quite severe. Just drawing to a close, just want to quickly share some of the sorts of data that you can extract very, very quickly from drone surveys, which maybe hopefully will stimulate some ideas in the audience. Images on the left are glacial outcrops in 3D, perfect photogrammetric models. It just shows you that very, very quick time you can collect an electronic record that's extremely realistic and extremely high resolution of any field area that you visit. The images on the right, I'm not going to go into trying to explain all those complicated graphs and things, but these are basically maps of dikes, and the graphs are showing you the amplitude of the dike as you walk along strike. So this is measurements from the digital, from the 3D digital models, and the point that study was making is that there's observations that you can get from the digital data that you cannot even make yourself physically on the ground because the subtlety of the signals were so high resolution and over such extended lengths that you can't observe it manually, and it only came out in the data afterwards. These are examples of what you can obtain from the hyperspectral remote sensing images, measurements of things like ground contamination, mineral maps, and the video that's playing was using a photogrammetric model as well to quickly extract geological boundaries and then turn things into a 3D model. And then finally, that same instrumentation, the hyperspectral instrumentation, is even now being used in combination with machine learning and ground sampling to collect things like water chemistry. The map on the left is the famous Rio Tinto stream, one of the most polluted rivers in the world, thanks to thousands of years of mining. That shows you a map of the distribution of iron precipitates along the sediments of the stream. But the other images are the water chemistry itself, and taking water samples and linking it into the visible near-infrared part of the spectrum. The scientists were able to extract pH, iron concentration, and redox downstream in quite high resolution. So I think we're going to end there. I just threw out some ideas of ways we could potentially scale up in the future, but for the sake of time, I might end at that point.
How good. We have time for one question. Yes, thank you so much, Stephen. Do we have a question? Question. No? Yes?
Back. Can you say that one more time?
What kinds of electromagnetic instrumentation are you considering? Because that was a really cool idea, dropping like a magnetometer somewhere to collect data for weeks, I'm guessing. But are you thinking of collecting EM data in the air?
Yes, that's correct. And actually, I'd love to have a conversation with you about that because we're at the stage of reviewing what's out there on the market. And if you have recommendations or even just guidance on the sorts of things that you would need, then that's exactly what we're looking for. And you've just reminded me, I have to add a slight negative tone. I unfortunately have to fly back to Brisbane this evening. So if anyone wants to catch me and talk to me about this, then do so in the next breaks and at the end of the day. But let's catch up.
How good. Thank you again. So just before we go to morning tea, we do have an interactive little bit. We're going to get to know each other some more. So what I'm going to get you guys to do is to stand up. And this time, I'm going to encourage you to not be with, you know, like maybe you work, maybe you got some colleagues in the room, yeah? Avoid them, right? We're going to aim for people that either we don't know or we don't work with. And I'm going to get you to form little groups of 3. It's fine to be in a pair as well, but ideally you'll be in a group of 3, and your time starts now. Go and make a group of 3. Tick, tock, tick, tock, tick, tock. You have 10 seconds. 10, 9, 8, 7, 6, 5. I see you guys up the top. Have you made your groups of 3s? 4, 3, 2, 1. So part of coming to a conference, like this, if I can get your attention for just one moment, is just there's a lot of resources that goes on or that's invested into coming along to a day like this. And we're very grateful for that. One thing that would really help AuScope out is a bit of a brainstorm. So we're going to get you to brainstorm a couple of questions. And then actually we're going to have a QR code, I believe, on here for you guys to fill out some answers. So the first question that we're going to ask you guys in your group of 3 before I come back on the mic is if you had $10 million, what science or research infrastructure could you guys build together? So have a bit of a brainstorm, and then after this, you're actually going to fill it out using a QR code on the screen in just a moment. So have a little chat among yourselves. You've got 2 minutes. Off you guys go. What would you do? So we're going to do the first question is yes or no, and the next question is yes. Okay. Let's see how it goes. We'll just wing it. Yeah, why not? If it works, good. If it doesn't, we'll just ignore it. You can be as creative as you like. What would you do with $10 million? If that's okay. They'll all be on their phones. 60 more seconds. We're about to show the QR code where you can put some information online, maybe. All right, so one thing that's really going to help AuScope out is if we can do a bit of data collection. So if you can scan this, we've got 2 questions for you guys, which hopefully should turn up. First of all, did you find something that you guys can collaborate on? A yes or no answer. I'm going to do it myself, see if it works for me. Nope, I'm at too much of an angle. It's working. So it is a yes or no question. Did you find something to collaborate on? Help us out, fill it in, because we're going to change questions in just a moment. Now is your time to scan. If you hit yes, you might help AuScope out. If you hit no, well, at least you're being honest, even if it makes AuScope sad. $10 million. Yes or no? It is a binary choice. There is no maybe. Very definitive. We are at this conference. Yes or no? You have 20 more seconds. If you can help AuScope out, click yes or no. And then we're going to change question in just a moment. If you haven't already pulled out your phone, please do. The site can't be loaded. It worked for me. Go to the guest. If you don't have internet, go to Wi-Fi guest. There is no password. You can just go straight on it. Don't tell ASIO. There is no password. All right, 5 more seconds. Yes or no, yes or no. We've had 21 people click in. There are more than 21 of you in the room. Ah, 1 per group, that's fine. Here I am being the Slido inspector. All right, are we gonna change questions? We're changing questions. Joe down here is changing the question. Oh, here we go. If you said yes, if you said no, you're safe, you can chill out. But if you said yes, can you share who and how? Again, it'll just really help out AuScope. We're not grading this. You might have had a ridiculous suggestion, that is fine. Yes, the who is who are you, which I assume you all got. If you write Dave Crescente, that is who am I, which I do appreciate, but who are you? And the how, your methodology, what are you guys gonna do? I know you geo people love talking about methodology. Can be an essay. It doesn't have to be an essay. Who is you? All of the above. Give us your address, your date of birth. No, ideally your name and organization. Just that'll help AuScope out. Is that correct? Name and organization? I'm getting nods. Name and organization. Maybe of the 3 of you. Think of this as giving back to AuScope. Really helps them out. And who knows? Maybe if they do get $10 million, they will be able to do your idea. Maybe they'll name it after you.